Welcome viewers. Today we will be doing experiments related to chemical equilibrium. Chemistry is full of chemical reactions. A chemical reaction can be represented as A plus B giving rise to C plus D. Here A and B are reactants and C and D are products. We can write an irreversible reaction as A plus B giving rise to C plus D, where A and B are reactants and C and D are products, and we write an arrow pointing towards the direction of the reaction. That means, A and B react to give the products C and D, and this is a kind of irreversible reaction because the reaction is proceeding only in one direction and we are getting C and D as products from the reactants A and B. But there are some other reactions in which once A and B react to give the products C and D, the products formed which are C and D now react again to form the reactants A and B. That means, now the products are acting as reactants and the direction of the reaction has reversed. Such reactions are called reversible reactions. And how to represent these reactions? You know that we have written a single headed arrow for representing the reaction between A and B to give C and D, which was separated by a single headed arrow. But in case of reversible reactions, we write an arrow which is different from that. What is that? We write such a reaction by writing two half arrows pointing in the two different and opposite sides, indicating that the reaction is taking both in the forward direction as well as in the backward direction. Let us write the rates of these reactions. The rate of forward reaction can be written as R1, which is equal to K1. Then we are writing the concentrations of A and B in the square brackets. So, rate becomes equal to K1 concentration of A in square bracket and concentration of B in square bracket. Similarly, we can write the rate for the backward reaction, which is R2, which is equal to K2 into the concentration of C and concentration of D. You can see here that the concentrations of C and D are written in square brackets as was done in the earlier case for A and B in the above equation. At equilibrium, the rates of the forward and the reverse reactions are equal. Therefore, we can write the rates to be equal to each other. Therefore, we can say that K1 into the concentration of A and concentration of B should be equal to K2 into the concentration of C and the concentration of D. Now, rearranging this equation, we can write K1 upon K2 is equal to the concentration of C into the concentration of D divided by the concentration of A and the concentration of B. Now, we can write now K1 upon K2 as K equilibrium, which is another constant, and we can write it as Kc, because now we are using the concentration terms both for the reactants and the products. Therefore, this equilibrium constant Kc is also known as concentration equilibrium constant. So, for a given reaction, the equilibrium constant, that is Kc in this case, is constant at a given temperature. That is one point to be noted. Today, we will perform a reaction in which we will be making ferric chloride to react with potassium thiocyanate to give us a very colored product. You must be curious to know what exactly is the reaction. So, we will write the reaction as Fe3 plus in aqueous medium reacting with SCN negative ions to give the product. Now, this reaction between ferric ions in aqueous medium and SCN minus ions in aqueous medium gives rise to FeSCN2 plus ions in the aqueous medium as the product, and while we perform this experiment you will see that we will be getting a very colored product in this case, and K equilibrium for this reaction can be written as the concentration of FeSCN2 plus divided by the concentration of Fe3 plus into the concentration of SCN minus in aqueous medium. So, let us start doing the experiment. For this we will be first taking ferric chloride, and the amount we will be taking is 0.100 gram. Similarly, the amount taken for the potassium thiocyanate 0.100 gram. The apparatus required for this experiment is shown here. I am taking here 3 beakers of 250 ml capacity with me. This part of the experiment will be using initially the 5 test tubes A, B, C, D and E only, and rest of the 4 test tubes will be used for the second set of the experiment or second part of the experiment. 9 test tubes which have already been labeled as A, B, C, D, E, F, G, H and I, and a balance for weighing and wash glass to keep the reagents, spatula, glass rods for dissolving these salts and water for dissolving the salts and the measuring cylinders. In addition to that, we will be requiring the reagents which are taken in the burette. So, in total we will be requiring 3 burettes in the first part of the experiment. Let us now start doing the experiment. We will first weigh the required amounts of the reactants using this digital balance. Now, I have already weighed the required amounts of the reactants, and first I will dissolve ferric chloride in beaker A. I am transferring ferric chloride to this beaker, and then I will add 100 ml of distilled water in this and make a solution by stirring. So, you can see that ferric chloride has dissolved and we have made a solution of ferric chloride. Similarly, we will dissolve potassium thiocyanate in another beaker which is labeled as beaker B. Again, I will add here 100 ml of distilled water and make a solution. So, now I have got both the clear solutions. The third step is to take an equal amount from these 2 solutions into another beaker, beaker C. I will be taking 20 ml of this solution of ferric chloride and 20 ml of this solution of potassium thiocyanate and mix them in this third beaker. Reacting these 2 reagents has been taken in this burette and the product is FeSCN2 plus ions in aqueous medium, and I have taken this solution in this burette. Now, let us do the reaction. I have got the solutions of these 2 reactants with me. I will transfer them into another beaker and you just observe what is the color being changed here. I will take ferric chloride first into this and then add the second reactant while stirring, and just see the color change happening. You can see here a blood red colored solution has formed here. I will take 40 ml of this solution in this burette which is labeled as D, and from this solution now we are going to actually start what was the aim of this experiment, that is to study the shift in equilibrium or the shift in the direction of the reaction by changing one of the reactants, which were ferric chloride and potassium thiocyanate. Now, this equilibrium mixture is there. You see, it is a reversible reaction. That means that the reaction is happening both in the forward and the reverse direction. And to now check what happens when we actually change the concentration of one of the reactants, we will first take an equal amount from this solution or the equilibrium mixture into 5 test tubes A, B, C, D and E. In the first test tube, I will transfer 2.5 ml from this burette. I am noting down the meniscus here. For a colored solution, you know that we have to take the reading from the upper meniscus, and I am carefully transferring 2.5 ml to this test tube A. Similarly, I will take another test tube B, C and D and E and take 2.5 ml of this equilibrium mixture in these 5 test tubes. Once again, I will clarify what I am going to do is I have taken 2.5 ml of this equilibrium mixture in each of the 5 test tubes A, B, C, D and E. So, 5 test tubes are now having the equal amount of this equilibrium mixture, and I want to change the different amounts of FeCl3 solution by adding different amounts of FeCl3 to these different test tubes and compensating whatever is the required volume of the solution to be made up to 20 ml. I have kept the target. I will add that amount of water to it. Now, I have taken 2.5 ml of this equilibrium mixture in this test tube A. Similarly, I have added 2.5 ml of this equilibrium mixture to the other 4 test tubes also, that is B, C, D and E. Now, I wish to vary the concentration of FeCl3 by adding ferric chloride solution from this burette A and see how different amounts of addition of ferric chloride solution affects the chemical equilibrium or the direction of the reaction, but the total volume of the contents in these test tubes should be same. So, whatever is the rest or the balance amount is required to keep all of them as equally filled, I will add that amount of water from this burette, which is burette C. I want to make now a total of 20 ml of this solution or the contents in this test tube. I have already got 2.5 ml of the equilibrium mixture. I am not adding any more ferric chloride solution, but to make the solution equal to 20 ml, I am adding 17.5 ml of water to make the contents equal to 20 ml. So, from this burette, I am adding 17.5 ml of water. Now, this test tube contains a total of 20 ml of the contents, in which 75 ml of water is there and 2.5 ml of this equilibrium mixture is there. This A test tube I will keep here aside to compare the results what I will be getting after adding different amounts of ferric chloride solutions to the 4 test tubes B, C, D and E. I have already taken different amounts of water required. Here in this B test tube, I have taken 16.5 ml of water. I will add 2.5 ml of this equilibrium mixture from this burette as I was doing for the test tube A. So, here I have in this test tube B 2.5 ml of the equilibrium mixture and 16.5 ml of water, and still one more ml is to be added, and that is the amount of the reactant to be added here, which is aqueous solution of ferric chloride. So, I will add 1 ml of ferric chloride from this burette. See the color changes what are happening here. See, the color has now darkened, that means ferric chloride, the additional amount we have added is doing something in the reaction mixture. So, what it is doing we will discuss later. Similarly, I will take test tube C here. Here I have already taken 15.5 ml of water. Now, equilibrium mixture is to be added, again the same amount 2.5 ml here. Now, in this case in C we have 16.5 plus 2.5 ml of solution, and I have to add 2 ml of the ferric chloride solution now. I will again shake this test tube to make this solution uniform, so that the contents dissolve and react. I am shaking this and I will keep it there in the stand. Take the third test tube here D, add the same amount of this equilibrium mixture, that is 2.5 ml. Shake again to dissolve or mix the two, and then add 3 ml of ferric chloride solution. I will shake again to mix it properly, and this D tube also, after shaking little bit more, I will keep in this test tube stand. And now, this test tube E, already now I have taken 13.5 ml of water in this. I will add again 2.5 ml of this mixture. Shake it again and add 4 ml from this ferric chloride solution very carefully by noting down the amount being transferred. I will shake the contents again, so that they react completely and we get a uniform concentration throughout the contents. Now, the time is there to compare. You see what we have done by all these additions is, I will just keep this test tube here E. I have taken equal amount or the same amount of this equilibrium reaction mixture, and I have added different amount from this burette, that is 1 ml in test tube B, 2 ml in test tube C, 3 ml in test tube D, and 4 ml in test tube E. That means, we have added varying amounts and varied the concentrations of ferric chloride in these test tubes, but we have not done anything to this test tube A. That means, we have not added any more ferric chloride solution to this test tube A, and now we will compare what has happened to the colors of the contents of these test tubes. That means, we will compare the color of this solution with the colors of each of these test tubes. The reagents or the reactants which have already reactants, we will now compare the colors. You can see here there is a difference in the color. In test tube B, the color is little darker than those of the contents in test tube A. Again, I will compare again. For reference I will be using only A. Now comparison with B is shown here. Again comparison with C is being shown, still more darker than B. Similarly with D, A and D are now being compared. You can see clearly the darker shade in test tube D than A. Again in test tube E, I will compare and show the colors like this. Now this is still darker. So the grading or the shades vary in a direction from B, C, D and E. That means the more of amount of ferric chloride we have added, the more intense are the colors in these test tubes. Why has it happened? Can you think of that? You see, the equilibrium mixture contained in this burette was FeSCN2 plus is there, and we are adding now additional amount of ferric chloride reactant. That means we are studying the effect of changing the concentration of one of the reactants, which is ferric chloride, on the equilibrium of these reactions. So what has happened exactly is that when we are adding Fe3 plus ions to a equilibrium mixture, the additional amount of Fe3 plus ions are shifting the direction of reaction towards the forward side. That means more of FeSCN2 plus ions are being formed, and these ions are being colored, are changing the shades of this contents of these test tubes. Now the shades are becoming darker, as we have already seen that means that the more amount of FeCl3 we have added, the more has the direction of the reaction shifted towards the right hand side, and the reaction is taking now more on the forward side, I would say, in another words. So forward reaction has now been pushed by the addition of these FeCl3 ions. So we can clearly say that the addition of one of the reactants to these test tubes by varying amounts have really shown a shift in the direction of the reaction and shift in the equilibrium side, you can say. But what has happened to the K? Has it also changed? No. All these changes have taken place to keep the K constant. That means that equilibrium constant has not changed, and it can remain constant only if by addition of Fe3 plus ions more of FeSCN2 plus ions have formed. So we have seen the addition of one of the reactants to this equilibrium mixture, and this was the first part of the experiment. Similarly, I can now change the other reactant, which was potassium thiocyanate, and add its varying amounts to the equilibrium mixture and see what has it resulted to. So I will now take another set of 4 test tubes here. I have labeled them F, G, H and I. For comparison, again we will be using only the reference, the contents of A for color comparisons. I will just remove B, C, D, E to this side. This I am keeping for comparison, and what we will do now with potassium thiocyanate solution is what we have already done with the ferric chloride solution. Similarly, in these test tubes also I will be taking 2.5 ml of this equilibrium mixture. I will fill all these test tubes like this, carefully noting down the volumes, upper meniscus, keep it here. In third test tube also 2.5 ml, again same volume. In the last test tube also same volume will be transferred, 2.5 ml. And next we will add different amounts of water to make the contents equal to 20 ml here also. And similar to the earlier part, we will now add potassium thiocyanate in different amounts, that means in different volumes, to change the concentrations. And in first test tube we will add 1 ml of this reactant, in another we will add 2 ml, in third we will add 3 ml, and in other last one we will add 4 ml of potassium thiocyanate, and add rest of the amount. To make the contents 20 ml, we will add water. So, I will do this stepwise. I will add 1 ml in this test tube F. See the color change. I have to still add water to it, but I am just keeping it here. I will add 2 ml here. Shake it and keep it here. Add 3 ml now. And then 4 ml are to be added in the last test tube. Now, there is time to add water to these test tubes to make the contents equal to 20 ml. Now, this is containing 1 ml plus 2.5 ml already, 3.5, and rest of it means that 16.5 I have to add. You can see that I have added 1 ml, 2 ml, 3 ml and 4 ml of potassium thiocyanate solutions to these test tubes, which are labeled here as F, G, H and I. The equilibrium mixtures amount was same, that is 2.5 ml in all these, but we have changed the concentrations of one of the reactants, that is potassium thiocyanate, in these test tubes. But to compare the colors, we have to now make the contents equal to the contents of this tube, that is 20 ml. Now, I will be adding 16.5 ml of water to this test tube, which is labeled as F. You can see here this addition. I will just keep it shaking also. Shake a little more and then add rest of the amount while shaking, so that the contents become again here 20 ml like this. I will keep this test tube here after shaking the contents. Take the next one. Here I have to add 15.5 ml of water to make the contents equal to 20 ml. I will keep on shaking as well. Add some more water to make the volume equal to 20 ml. It is done. It is 20 ml now here also in total. Again shake it well and keep here. Take this third test tube labeled as H and add 14.5 ml of water to make the contents again equal to 20 ml. Just shake it a little. I will remove and shake. I am still adding more water to make the contents equal to 20 ml, and now it is 20. So, I will just stop the addition. Shake the contents again to make them uniform, so that we can easily compare their colors. Keep it here and then take this last test tube labeled as I and add 13.5 ml of water to make the contents equal to 20 ml. I will keep the contents of this test tube shaking. I will just take it out and shake to make the contents uniform. Add some more water and now it is total 20 ml in this test tube also. I will shake it a little more and you can see that there is a clear color change. Color is quite dark in this test tube. I will just keep this also here, and now what I have to do is I have to compare the colors which have been obtained by adding varied amounts of potassium thiocyanate solutions to these test tubes 1 ml, 2 ml, 3 ml and 4 ml, while the amount of equilibrium mixture was kept constant in all the 4, that was 2.5 ml. And here also in test tube A, I have 2.5 ml of this equilibrium mixture, which I had already done in the previous part, and added 17.5 ml of water. So, contents are again 20 ml. And if you compare the colors of contents in these test tubes with that of A one by one, you can easily see that there is a change in color. In test tube F, the color has become darker as compared to that in A. Next comparison is for that of the test tubes A and G, still darker color as compared to this as well as to the contents of this test tube. Again third test tube H1, comparisons of the colors, you can see here quite an increase in this tone of the contents in this H test tube as compared to A. Finally, comparison of the colors of the contents of test tubes A and I shows very distinct dark color in this test tube I. That means the addition of more of the reactant has really led to a change in the direction of the equilibrium while we proceeded from this test tube to this test tube. That means the increase in the amounts of the concentrations of the reactant potassium thiocyanate has shifted the equilibrium again to the side where more of FeSCN2 plus ions have formed. Now, you can see that what we have done today is we have used varied amounts of the two reactants, that is we have added different amounts of ferric chloride solution, which was one of the reactant, to these test tubes. Similarly, we have varied the amounts of the another reactant potassium thiocyanate in these test tubes, and if we compare the results obtained with the intensity of the color in this test tube where no more reactant had been added, we can easily see that the color intensity has increased as we move from this direction to these directions. That means, the more of the reactant added has intensified the colors. That means, the reaction has shifted or the direction of the reaction has shifted in that direction where more of FeCNS2 plus has formed. That means, the more of the product has formed. So, there is a shift in the equilibrium, but there is no change in the value of the equilibrium constant of this reaction, which remains the same. You can easily see this equation here and see if we add or increase some amount or some quantity in the denominator, whether it is Fe3 plus ions or SCN minus ions, and increase the value in the denominator, we have to correspondingly get an increase in the value of the concentration of the product in the numerator to keep the K constant, and this is well in accordance with the Le-Chatelier principle, which you have already studied. So, we have actually seen that how the change of concentration of reactants actually affect the direction of the reaction, and there is a shift in the direction of the reaction when we change the concentration of one of the reactants. Now, before we say that we have done this experiment on chemical equilibria to understand the change in the concentrations of the reactions, you should keep in mind that whenever we do such an experiment, we should always use the same amounts of the or the contents or the same amounts or the same volumes of the reactants taken in different test tubes. Otherwise, the color intensities will vary in case we have taken different amounts here. And second thing to be kept in mind is that we have used only dilute solutions. Why? Just think it over. One more thing before we wind up this session is that whatever observations we have done about the colors in these test tubes, you should record them while doing your experiments in the laboratory. That whenever you add different reactants, observe the color, note down in the table, which is the observation table already available with you, or if not available, then make a table of that kind and record your observations in that table, so that at the end you are able to easily interpret what you have done and what is the result and outcome of the experiment, and what was the principle behind it and what are the results. You should be able to discuss amongst yourselves.